I'm Ahmad Zouel. I am in the chair professor here at the California Institute of Technology in both chemistry and physics. To me, light is life. It's as simple as that. As a matter of fact, I did give a lecture in India called Light and Life. It is on the human scale, light is the one that makes us see and understand and comprehend the beauty of nature. Light also, from the point of view of knowledge, is the one that removes the darkness that exists in the world today. All these wars and what's going on around the world is actually because we are not seeing well what's going on with humanity. But when it comes to scientific domains, photosynthesis is depending on light. So we can't have food without light. We have to understand these processes. Light is essential in every chemical industry, pharmaceutical industry. We need to use what's called the catalysis in order to convert substance A to substance B. This is done also through using light. I wouldn't say it's even applications of light. I would say light is in the fabric of our life, and so it is really important, and I think this was a very good decision by the UN and UNESCO to celebrate next year the Year of Light. Let me tell you, because it relates to my own background, the first calendar that humanity knows about, or humans knows about, was made in the land of Egypt, and in the year 4241 BC. That's a number, BC. They were actually observing a star called Sirius, or Cyrus, sometimes you call it. And they notice its disappearance and reappearance again in 365 days, defining now the solar or the... so this is a light calendar in a way, because you are observing actually what's happening to the light that's coming out. And they could clearly define the first calendar that we know. They even got the leap year right, because they noticed there was a delay every 4 years, you see. So that's light, and that defines for us, for all civilizations. Of course, it got more accurate with the Romans, but it is clear that light played a fundamental role in even defining time for humanity. Today, when I hear about the conflicts of religions with science and all of that stuff, it's also in the same region where the three, Judaism and Christianity and Islam came in the same place, but yet in the same place 1,000 years ago or about, it was really the center of civilization as far as the development of science. Of course, there were places like the Alexandria Library, for example, 2,000 years ago, which I always say in my lectures was Caltech of the world, because, people from all the big guns from Greece, from Athens, used to go there in order to, that's what happens with Caltech today. People come from all over the world to get the knowledge. It was Alexandria Library, but that's 2,000 years ago. 1,000 years ago were interesting enough, because Egypt 2,000 years ago was about to go to Christians' faith. But on the other hand, 1,000 years ago, it was Muslim scholars So today when we hear about Islam and some of the problems that exist in the world, actually during that time, I give you an example of one scientist that's relevant to what we're talking about. And his name is Ilhazen in the West. It's called Ilhazen. In Arabic, it's called Hassan ibn al-Haytham. Ibn means the son of. It's like, I think in Hebrew, Ben. And so there is this analogy. So Ibn al-Haytham developed the many things. They used to think that light, in order for me to see you, that I have rays of light coming from my eyes. It was Ilhazen who pointed out that that's impossible, and that the reason we see it's a reflection from objects and they come in a straight line into our eyes. He also showed in a brilliant experiment what's called camera obscura. Camera obscura because he made a pinhole in a dark box, and he could see the images. If you put an image of a candle, for example, here, it comes out there inverted. Well, that's a camera. That's the whole concept of the camera. But more importantly, and that's what Newton, Descartes, and people like that built on, is that means that the light is going in straight rays, you see. Otherwise, it will not invert as such. So that was a concept 1,000 years ago. It's extremely important, and he estimated also the speed and so on. So that part of the world has had peaks, shall we say, of development and progress that was leading the world. And there are many other names that I don't want to take your time with for that region. But like everything else, sometimes you get declines in these things. And that's what happened over the last several hundred years. There's many reasons for that decline that also needs, is not appropriate for this occasion. But we are trying very hard now in the last 20 years or so to rebuild the knowledge base in this part of the world. And I'm happy to see that we have established, for example, in Cairo now, a whole new center of excellence. It's a city, actually, and the government has kindly named it after me, and we are having frontiers research that's going on right now. And there are other places in the Middle East now that building up also other centers of excellence. So our hope is that this region will regain some of its glory or past glory. I do believe that the soft power of science is critical. If the world is not going to be educated and enlightened about what's going on, we're going to be in deep trouble in this world. And therefore, I like to see that we in the United States invest a lot more in a way of education, helping science, producing more food, helping more skills in these countries to develop their own. I think that's much better than F-16 and much cheaper. And that's what I have written about, and I think it's good for the future of both, of the United States and the world at large. We have to be careful. We have to really, really, in this country, worry about the issue of education and the investment in basic research. But in my view, globally, we will be all better off if we increase or enhance education on the level of the world and support knowledge. Knowledge is the key. Knowledge is light, you see, and that's very important. Technically, we used for the Nobel, the stuff that recognized by the Nobel, were about the ability of using very fast lasers, femtosecond lasers, which are bursts of light in the millions or billions of a second. But we recognize that the movement of individual atoms during the course of a chemical or a biological change, that these atoms move on the time scale of the femtosecond. So we developed techniques, in a way, it's a camera, that can take record the time scale for the movement of atoms when a substance go from form A to form B. And that opened up all kinds of studies in terms of the dynamics of the chemical bond or biological systems. But after the Nobel, I wanted to see the object itself. So there, before the Nobel, we had the time we can measure and we can study. But what is the structure of these objects? If you have a protein in you right now, it does the movements of all of these thousands of atoms, and it goes from one form into another. How can we see this form? So we developed what's now known, and Caltech has many patents on it, and we have published our work all over the place, what's called four-dimensional electron microscopy. It's imaging now. So we converted from time measurements into imaging in the 3 dimensions of space and in the 1 dimension of time. And this 4D visualization allowed us with electrons, because with light you can't resolve the structure. With light the wavelengths is because of diffraction, you will be only able to reach certain limits. But with electron, which we generate, by the way, using light, but with these electrons, you can see the atom, and you can see the structure, the whole structure. And so as a result of that, there's a field now called four-dimensional imaging or four-dimensional electron microscopy, and my group and many now other groups around the world are using these techniques in order to study materials, biological systems, chemical systems, and so on. To be honest with you, that all my life I have been after the fundamentals and how can we cross new field. And but people, for example, out of this 4D electron microscopy, now a FEI, a major company in the world, has had an agreement with Caltech, and now the manufacturing these new imaging microscopes, and they are selling all over the world. So here is a whole new technology that they can do. But my thinking originally was all driven by curiosity. If you are passionate about something, you will enjoy it for the rest of your life. And it will not be a job. Until today, my wife will tell me, the moment where I become a child and coming home so excited is when there is something truly exciting I'm doing in science. And so why? Is because all my life I have been passionate about this. So my message to the young people, search the landscape and find what you're really truly passionate about. And for the rest of your life you will be happy. It's not money in a big way, it's not influence and power. All of these things come and go, but I think if you are passionate about a profession, you'll be happy.